Hello, welcome to the maths class. Today let us learn about grouping data into class intervals. What are the different types of class intervals? How to group the data into class intervals? You are going to learn today. Before that, let me explain you. There are two types of data. One is two types of data. One is continuous data, other one is discrete data. What is continuous? What is discrete data? Discrete data means the data which has only whole numbers. Let me give you an example of discrete data. The number of members in a family, number of students in a class, these come under discrete data. Number of members in a family is either 2, 3, 4, 5 or any other whole number. Same way, the number of students in a class also is a whole number always. That is our discrete data. Whereas continuous data may be a whole number or maybe a number between two whole numbers. Let me give you an example for continuous data. Height of students, the heights of students, the age of children, heights of students may be 4 feet, maybe 4.1, 4.2, 4.3. See, it need not be on exactly 4 feet or 5 feet or 6 feet like this. Same way the age of the children. It may not be 3 years, 4 years, 5 years, maybe 3.1, 3.2, 3.4 years and so on. So discrete data means the data having only whole numbers. Continuous is any number. It may have whole number or any other number in between two whole numbers also. Now let us come to what are class intervals, how to group the data into class intervals. Suppose the given data is, I will give you the marks secured by some 15 or 20 students of a class. Let me give you the data. Suppose in a class of 20 students, let me say, out of 25 marks, test is done. The marks secured by students, let me write 10, 20, 25, 16, 20, 14, 9, 8, 1, 2, 3, 4, 5, 6, 7, 8, maybe 7, 10, okay? Let me give 10, 15, 20, 17, 25, 24, 23, 16, okay, 9, 10. So I gave 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. These are the marks secured by 20 students of a class out of 25. I have given the data, given data. How to group these data into class intervals? In order to convert this, find the class intervals, what you have to do is the least variate or observation, or here the marks, and the highest marks you see. And here in this case we can know the marks are out of 25. So it is below 25. So we can take as 0 to 5. Okay, the 1 to 5 or 0 to 4, 5 to 10, 5 to 9, 0 to 5, 5 to 10, 10 to 15, 15 to 20, 20 to 25. When I say that you may confuse, we can take as 0 to 5, 6 to 10, 11 to 15, 16 to 20, like that we can take. Nobody got 0 here, no need to take this. So here we can take the class intervals as 1 to 5, 6 to 10, 11 to 15, 16 to 20, 21 to 25. And 1 to 5 a class interval, next 6 to 10, 11 to 15, 16 to 20, 21 to 25. Here 1, 6, 11, 16, 21. These are said to be the lower limits of the class intervals, and 5, 10, 15, 20, 25 are said to be the upper limits of the class intervals. So the first one is lower limit. This is upper limit for every class interval. Okay. Then what is the class mark? The mid value of each class is set, each class interval is a class mark of the class interval. In this case, the mid value is in between 1 and 5. The mid value of 1 and 5 is 1 plus 5, 6 by 2 is 3. Here 3 is the middle value. Here 8. Here 13. Here 18. Here 23. So the mid value of each class interval is known as a class mark. What is class mark is? The mid value of each class interval. Each, in short, let me write for class interval as CW. Okay. So the class mark is the mid value of each class interval is the class mark. And the class size is actually upper limit minus lower limit. Upper limit minus lower limit is the class size of the class interval. Actually, about class size, the class size or class width, you are going to learn in when I explain you the other type of class interval. Here grouping data into class intervals, I said. Again, there are two types of class intervals. One is overlapping, other one is non-overlapping. Here we can see nothing is overlapping. Upper limit of the first class interval is 5. Lower limit of the second class interval is 6. So for this, let me explain, show you the frequency distribution table. Okay. First, I will show you the frequency distribution table showing the class intervals, how the marks of 20 students of a class. Whenever you do a frequency distribution table, you have to write the heading what you are going to show. Frequency distribution table showing showing the marks of 20 students of a class. And here less space again, if I rub it will be okay. Let me do class interval here. Tally marks already you have learned in the previous class, but their class intervals were not there, only individual observations we have taken. Here class intervals we have to take. Let us take the class intervals like this: frequency 1 to 5, 6 to 10, 11 to 15. Here no space. For time being, let me write here 16 to 20, 21 to 25 tally marks will write here. Then I will clear it and write. 10 comes under here, 20 here, 25, 16, again 20, 14 here, 9, 8, 7, 10. Already you know after 4 tally marks, last one. The fifth one will be like this. Again 10, 15, 20, 17, 25, 24, 23, then 16, then 9, again 10. So 1 to 5, no student got from 1 to 5 marks. So frequency of 1 to 5 is 0. Frequency of 6 to 10 is 5, 3, 8. Frequency of 11 to 15 marks is 2. Here we got 6, 4. Let us see. 6, 4, 10, 8, 18, 20. Yes. Now I will write here. And because of lack of space I wrote there. But now I am writing this side. So 16 to 20 we have 1, 2, 3, 4, 1, 6. And here 21 to 25 we have 1, 2, 3, 4. So this is the frequency table showing the class intervals and the corresponding frequencies. By this we can know no student got 1 to 5 marks, 8 students got 6 to 10 marks, 2 students got 11 to 15 marks, 6 students got 16 to 20 marks, and 4 students got 21 to 25 marks. And these class intervals are said to be non-overlapping class intervals. These all are said to be non-overlapping class intervals. These class intervals are said to be, let me write here, these all are non-overlapping. We can see upper limit of first class interval is 5, lower limit of the second class interval is 6. Okay, so they are not overlapping each other. Then what are overlapping? Let me explain you. Okay, so this is non-overlapping class intervals I have explained you. Now let me explain you what are overlapping class intervals and how to show them. Okay, and if it is a non-overlapping class intervals will be given to you. If you have to convert to overlapping class intervals, how to convert also I am going to explain you. Okay. If the class intervals are 0 to 5, 5 to 10, 10 to 15, 15 to 20, 20 to 25, these are said to be overlapping class intervals. You can see the upper limit of the first class is 5, lower limit of the second class interval is also 5. So these are overlapping class intervals. And let me give you just a simple example I am giving you. Suppose class interval. Okay, this one also let me explain you by giving data. Let me give you some data, anything. Let me have the number of books some children have, the number of books, some 10 students, how many books? One student has 4, other one 5, other one 3. Other student has got 5, other one 3, 4, 5, 1, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. Other one is having 10. 10 students have these many books. Suppose we want to this one frame frequent. We have to convert or show this in the form of class intervals. And remember children, whenever you want, and here very less data is given. Let me give you some more. Some 20 students, what number of books they have. Let me give somebody is having 13 books, somebody is having 15, somebody is having 11. Okay. Now let me give you 11 books, 12, 10, 11, 14, 15, okay, 10, 12, 13, 14. So 20 students, the number of books 20 students has got, I have given here. So in order to show this in the form of class intervals or in the form of frequency distribution table, you see the least number. Least number we can see 2, maximum is 15. 15 to is 13. Or we can say maximum is 15. We can divide these into minimum 5 class intervals to maximum 20. Whenever you do, you have to see that. So in this case, what I do is class intervals I will take as 0 to 3. Because 3 5s are 15. Okay. So that we can have 5 class intervals. Here frequency 0 to 3, 3 to 6, 6 to 9, 9 to 12, 12 to 15. You can see 3 3 repeating, 6 6 repeating. How to find? Let me see. 4 here, 5 here, 13 here, 5 again here. Now 3 came. Now you have a doubt. You will have a doubt whether 3 will be included here or here. So whenever you get that, 0 to 3 means from 0 to less than 3, but not 3. From 0 to less than 3. Mostly we use overlapping data for continuous data. So 3 will be added here, not here. It will be counted as the lower limit here. So 3 here, again 4, then 15, then 11 here, then 2 here, again 10, again 11, 12, sorry 12 will be here, not we should not count here. Lower limit we have to count. Again 10, 11, then 14, 15, here 10, 12 here again, 13, 14. So 6 to 9, no one is there. So one student is having from 0 to 3 books, 3 to 6 books are having, 5 students are having 3 to 6 books, nobody is having 6 to 9 books, and 5 and 6 students are having from 9 to 12 books, 5, 3, 8. 8 students are having 12 to 15 books. 8, 6, 14, 5, 19, 1, 20. Okay. So this is the frequency table, and you have to, we can write the heading just like previous frequency table showing number of books 20 students are having. Okay. And now let me explain you how to convert the non-overlapping class intervals to overlapping class intervals. That one, when you have to draw the histogram, that you have to know. So let me explain you conversion of non-overlapping class intervals to overlapping class intervals. Okay, let me explain you this, how to explain. In the previous example I told 1 to 4 or 1 to 5 I gave you, 1 to 5, 6 to 10, 11 to 15, 16 to 20, 21 to 25, these are the class intervals. These are non-overlapping class intervals. In order to convert to overlapping, what we have to find is, we have to find the adjustment factor. What is adjustment factor? Any class lower limit and subtract the upper limit its previous class interval. Subtract the upper limit of a class interval from the lower limit of the next class interval and divide by 2. 1 by 2 you get, that is 0.5. And now we have to subtract 0.5 from the lower limits and add 0.5 to the upper limits to get overlapping class intervals. When we subtract 0.5 from 1, we get 0.5. Here we get 5.5. Again 6 minus 0.5 is 5.5. 10 plus 0.5 is 10.5. Here 11 minus 0.5 is 10.5. Here this is 15.5. Here 16 minus 0.5 is 15.5. This is 20.5. And here 21 minus 0.5 is 20.5. And this is 25.5. So this is how we can convert the non-overlapping class intervals to overlapping class intervals. Okay. So this one you must know whenever you have to convert from non-overlapping to overlapping, and particularly this one will be useful when you construct a histogram, which you are going to learn in the next class. Thank you.